Hello guys, welcome back to join our session in which we revise for the fourth quarter exam. Okay, we solved it in session 1, page 1 and the first question in page 2. This question is question number 2 in page 2. Okay. Before I begin to solve this question, I'd like to remind you by something. It is very, very important. Look with me. Let's remind you by something first, okay? Wait, I'm sorry, new one. New, here. Look here, I'd like to remind you by something. It's very, very important. Look here, if you remember, what did the sketch? Some function, I like to remember their sketches. Some of these function. Look here, 1 over x. It is a reciprocal function. It has the function undefined at x equal 0. What is its sketch? Look here. Remember with me. It is drawn. This function is drawn in 2 quadrants. The first one and the third one. Okay. The first one, first quadrant and third quadrant, that is negative infinity, that is infinity. Okay. The second function I'd like to remember, okay, f(x) equal negative 1 over x. Okay, this function is drawn in what? In 2 quadrants. The second one, look here, the second in different color. Okay, second quadrant and the fourth quadrant. That is first, second, third, fourth. Okay, please try to remember. As we learned before, I think in the second quarter. Here, the other function f(x) equal what? 1 over x what square. Sometimes it's better for you to use the sketch of the function. It will save the time, okay, of the solution. It is drawing in what? In the first quadrant and the second quadrant. f(x), you have to remember these sketches. Negative 1 over x to power 2, it will be function drawn in which quadrant? Fourth and third quadrant. You have to remember the function is increasing if x goes to right, y goes to up. Okay? As here, look this one for example. As x goes to right, y goes to up, this means increasing. The function is increasing on this interval from negative infinity to 0, because the function undefined at 0. Okay? Because I have to know what is the values of x which divide the domain of the function. Maybe the value at which the function undefined or at the critical number. Here, but here, as you see, as x goes to right, y goes to down. It means decrease. The function is what? Decrease. Okay? Down, it means decrease, becomes smaller. This very, very important. Look here. This function up into up, so it will be concave what? Upward. That's right or no? Okay? Yes, don't worry. If the function open to down, it means what? Concave downward. Concavity, it means the curve of the function. Open up or open down. Here, concave downward. I hope to understand. I'd like to revise all of these things before I begin to solve the question which I talked to you about it. Okay, I know. The concavity, it means we have to use the second derivative test. Second derivative, or the second derivative I used. I have many ways to or sorry, not many ways again. For solve any problem, maybe we have many ways, but the benefits of using the sketch to save the time of the solution. Okay, here I'd like to remind you by another thing here before I begin to solve. Look here. If the second derivative at a value of point in a given interval more than 0, it means the curve of the function concave upward, concave open to upward. If the second derivative at a point in a given interval less than 0, it means the curve of the function concave downward. Okay? Now, I'd like to solve the problem. Look here. I hope to watch the video many times to understand what I explained. Look here. Given that fx equal negative 8 over x. Do you know the sketch of this function? I think it's so trivial to remember, as I showed you before. This function is drawn in two quadrants. Which quadrant? First and second, second and third. Which two quadrants? Look here, I sketched it. This function is drawn in two quadrants. The second, okay, and what? The fourth one. Because it is a reciprocal function and negative. The numerator is negative. Okay. In this case, as you see, this function is all of the given choices, all of the given. Look here, all of the given choices talk about what? Concavity. From the sketch of the function, I can identify the concavity. Here, if here negative infinity, and here what? Because that is x-axis, that is y-axis. Okay, here 0. As you see, the function concave upward, here, sorry, upward, I'm sorry, concave, what? Upward, as you see, okay? And here what? The function is what? Concave downward. I think you understand now. I prefer to use the sketch of this function. It's so easy to remember. So the function here, the graph of f, concave upward on the interval 0 and the infinity, no. 0 and the infinity, as you see, 0 to infinity, it is concave downward, this one, no. The graph of the function concave upward, yes, here, as you see, concave what? Upward on negative infinity to 0, that is why this choice B, our choice is B. That is by using the sketch. I prefer to use this one to save the time in the exam. If it is so easy for you to use the sketch, or it is easier for you to use the sketch, it's better to use it. Okay, but someone in the session, he told me, Miss, I don't understand this way because I can't remember the sketch of this function. No problem. I'll show you another way. What is the way? Since all of the given talk about the concavity, I use the second derivative test. What is the first step? Find the, here, no, before I begin the domain here, x not equal 0. This means at x equals 0 the function undefined. I need to rewrite the function. It will be negative 8 x to power negative 1. But I prefer the first way by using the sketch. If you don't understand, I use this one. If you understood by the using the sketch, it's better for you and use it. If you don't, I give you another way. This way for who didn't understand the first way. So the first derivative of the function, it will be 8 x to power negative 2. Write it in the simplest form, 8 over x to power 2. Okay? Second step, because I use the second derivative. So how to get this? I'm sorry. I don't need to write it in the simplest form before I find the second derivative. It will be negative 16 x to power negative 3, which is now I will write it in the simplest form, x to power 3, because I'll talk about the second derivative. But if I talk about the first derivative, or I'll use the first derivative, I will write it in the simplest form. But since I'll use the second derivative, I have to put it in the simplest form. Find the zeros where is the second derivative equal 0 or does not exist. So since the numerator equals 0, cannot be 0, so the second derivative cannot be 0, because here the numerator, it is what? Positive. Since the second derivative is rational function, the values of x at which is the second derivative equals 0, it will be the value of x which makes the numerator equal 0. But does not exist if the denominator equal what? 0. Here, second derivative cannot be 0, so does not exist at x equal what? 0. I can't consider at x equals 0, the point at x equals 0 inflection point, because it is undefined. So, I'll draw what? The line for the second derivative. I write here on this line the values at which the function undefined, or the values at which the second derivative equals 0 or does not exist. Since I don't have any values which make the second derivative not equal 0 or does not exist, and the values of x in the domain. So in this case, I will write where the function undefined. Yani on this line, I write where the function undefined and the values at which the second derivative does not exist or equal 0, but I don't have, so I will write only 0. Here negative infinity, and here what? Infinity. Test value as we did before. Here I will choose negative 1, and here I'm going to choose what? 1. Replace in what? In the second derivative. Okay, it will be positive. Okay, since it is positive, so the second derivative positive, concave upward. Concave what? Upward. Replace it will be what? Negative, since second derivative concave downward. This means the function concave upward on 0 to infinity? No, it is concave downward, upward on the interval, which one? Negative infinity to 0. So that is why here f(x) is concave upward on what? On which interval? Negative infinity and 0, concave downward on 0 and the infinity. Which choice is correct? It will be the second choice, which will be correct. Okay? I hope to understand. Look, I have done many steps, but if you use the sketch, it's better for you. For me, it's better. But if you don't understand how we use the sketch, use the second way. Okay? Look here. Give the sign of the second derivative of f at the indicated point. Here, that is the indicated point. Look here. Find the sign of the second derivative. Here's the sign of the second derivative. Look here. If the function concave upward, the second derivative is what? Greater than 0. Positive. Okay? If the function concave downward, the second derivative less than 0 or negative. Okay? Here, this point on the curve of the function, such that the function here concave what? Upward. The function what? Concave upward on this interval. So the second derivative at this point, it must be what? Greater than 0 or positive. It must be what? Positive, because the curve of the function concave upward, up into up. At this point, look, this point on the curve of the function such that the function open to up, it means concave to up. Since the curve concave to up, the second derivative greater than 0. Revise all of the theorems. Okay, so it is what? Positive. That is why we choose part B. Okay, it's enough in this session. Inshallah, I'll continue the solution of the worksheet, inshallah, in the following session. Thank you for joining the session. Bye-bye.